they approached to us. Now we have developed based on PTFE and HBN, hydrogenated nitrile butadiene rubber, and 2800 landing is passed through. Now we will be giving the technology to the industry so that they can manufacture, they can supply to them. So it is our development work. What I mean to say that once leather and nitrile rubber was suitable and used and fitted into the system, but as the time goes, the sustainability is not that much. That's why it is required to be replaced. And whatever we are making, it is for the time being, it is sustainable. You can say. Now, similarly, the another kind of material is the carbon-graphite material for aero engine. In aero engine application, the material requirement is minimum 600 degree stability or above. In those cases, rubber, polymer, nothing will sustain. So, carbon-graphite material is a material. In our case, in JVC, we have developed up to 600 degrees sustainability. So there are also in engine part and component also there are also small component like seal and other things also. Okay, so that seals are not made up of metal; these are made up of carbon-graphite material. So carbon-graphite seals and other things are also contributed from us. In LCA, the ejector setup valve, there are so many components are required, and for which we have developed the carbon-graphite material, piston ring, seals for aero engine application. Now, in the same context, what I tell to say, the after LCA, what India is thinking of, and is there any another plan to have another aircraft or something like that? So after LCA, it is advanced medium compact aircraft. It is a multi-role. It is projected. The aircraft is not yet sanctioned also. This is the advanced version with this stealthy feature. LCA is one engine. In this case, it will be two engines. Simultaneously, it will be stealthy. Stealthy means it could not be caught by enemy's radar. Okay, so this is done. Or you see, in all cases of development, you need to have a material. Without material, it cannot do. Whatever thought you are having, even the computer engineer, you need to have a computer. You may miniaturize it to the laptop, may miniaturize it to the tab, but even the tab on mobile also, some materials are related to this. So material is important. So although the AMCA is not yet sanctioned, hopefully it will be sanctioned after the election. The material, that project we have started. So this project, in this project, there is materials for airborne platform. The project came to us. We had that two important components to be developed, which should be one is the development of weakness mitigate using EM lossy materials for greater than 10 dB loss by 2 to 18 dB. In this radar absorption, radar radiation, it should not be caught. It is very important. While flying in aircraft, it is with its speed. Even a bird may be momentum of high speed. A lot of accident may happen. So the test is that 4-pound bar at a speed of 850 kilometers per hour. It should be able to sustain. So there are so many critical areas where you have to pass through. Only then you will be able to fit into the system. Another one, that canopy means the upper portion where driver is to sit. That is the canopy. Canopy is a PMMA, polymethyl methyl based canopy. Now, you can hide your aircraft in other portion also using the radar absorbing coating or stealthy coating or component and all those things. But the transparency should be there for the driver. In that case, how you will be protecting it? In this case, indium tin oxide is being deposited into this portion, which is the radar. But in a PMMA sheet where indium tin oxide will be deposited, during long term of your use and exposure, it may come out. So we have to give a transparent protective coating onto ITO again. But the visibility of the PMMA perfect sheet, PMMA should be there. So transparent protective coating for windscreen and canopy. So these are the two objectives. In big base a lot of work we have done with simulation and all those things, but it is not yet fully developed to give the prominent solution. To be honest with you. Similarly, what this is because of the ITO. This is the canopy, ITO coating when it will be like this, and you have to give it. But in this case, we are very much successful that ITO coated acrylic and ITO coated acrylic with this protective coating, if the radar performance, there is no significant change in the transmission loss, are almost same. So this product may go into the purpose of this. Is it clear? Now, in the evolution of our aerospace material, it is the end of my aerospace material that it is not the end of the solution of stealthy feature. There are so many features are predicted so that its aerodynamic flexibility. uh, Practice, I could see everybody's face. If face are so high, that means you are not. I could not catch you. Yeah, I could not connect you in my lecture. हम लोग से परिचय ही कर HPQ वो इस बटन बढ़िया बढ़िया मोहन को पता कुछ भी पहले ही था ना आगे के बाद Yeah, chemical engineering. PhD. Which food technology? So my final chemistry department है chemistry department आपका कॉलेज बहुत अच्छा है मैं फर्स्ट पे देखने को मिला फोर्थ ईयर ना All are. That's why I told you that I am not teaching. I give her just to tell some story. Because I have to observe you for 1.5 hours. What is assigned to me? You see in the aircraft industry. Let me start. The last slide. The future flight path in 2050. The future of aeronautics. You see all sustainability, what you are talking about, it lies here in case of your aerostructure or aero industry, aerospace industry. Environmentally goal 75% reduction in carbon dioxide emission and 90% reduction in NOx, because in this case it is not the renewable energy. You have to have used renewable energy like fuel. And the fuel standard is much higher than our petrol. The aviation turbine, 88 aviation turbine fuel and also. So in all cases, we could not see our bigger system of the earth. We could not see visibly, but effects came after the civilization of 300 years or so. That's why today we feel that yes, carbon dioxide, World War one thing is taking place. So it is not because of the earth what we are polluting it. It is polluting from the space also with the spacecraft and aircraft also. That's why that system is expected that this is the environmental goal where in 2050 our aircraft should have the capability that at present whatever carbon dioxide emission, nitrous oxide emission is there, that should be reduced by 90% or 75%. The passive noise emission noise is also a variable of flying aircraft is reduced by 60%. And air vehicles are designed and manufactured to be recyclable. Nowadays, even the composite also what I talked about. There are two types of composite. One is called the thermosetting composite, another is thermoplastic composite. Thermosetting composite, what said, you cannot reprocess it. Like your bakelite in your cooker's handle. Simultaneously, thermoplastic, it could be reprocessed. That's why in the composite world is also shifting. Epoxy-based thermosetting composite is well established. Okay, it used to get it in the very liquid form. Epoxy, it will be easily impregnated into the carbon fabric or glass fabric, and you can get the composite structure. On the other hand, high performance thermoplastic material like polyether ketone, polyethylamide, they are very high melting material. So in order to impregnate, the difficulty challenges challenges is that in order to impregnate at high viscous, at high melting point, to impregnate into the fabric to get a good composite is a challenging start, and that technology is not yet established. Simultaneously, because of the environmental that that garbage you have to recycle it. That's why the composite world is also changing from thermosetting composite to the thermoplastic. So air vehicles are designed and manufactured to be recyclable. Safety goes less than one accident per 10 billion commercial flights. Air vehicles are resilient by design to current and predicted on board and on the ground security threat evolution internally and externally to the aircraft. Development of aerostructure relies on the development with new materials with improved specific properties and novel manufacturing. New materials, as I told you, you have to have, if it is recyclable, you have to have take a new material maybe nature origin or maybe recyclable origin. Simultaneously, the novel manufacturing technique also the technique where your process will minimize its pollution and energy consumption. As a matter of fact, both lead to the sustainability, what we are talking today, sustainable materials and sustainable processes. So this is all about design, promote the design research. Aerodynamically, goes with so resistance or friction of the you see इतना लग जाए कुछ लग जाए हेवी हेवी उसके बाद बहुत जंजीर टाइप का है ना साइंस देखा है ना तो I told you one time bulletproof jacket again weight is 9.5 kg somebody is giving the solution 8.5 kg so we are we are jumping for reduction of the weight because it is a two composite system. In this case, the bulletproof jacket, in this case, the bulletproof vest is there. One is having a boron carbide with ceramic face, and the simultaneously supported by ultra high polyethylene composite, which can resist evenly. So, how the transformation is taking place? What I tell you, I told you the final story earlier that metallic and nowadays based on alternative. In between, how technology, one technology, established technology is being replaced by the another technology. When Kevlar, the polyaramide, 1538, price of steel plate. Steel plate is being replaced with the Kevlar composite because of the invention of the Kevlar. It is Kevlar technology. Polyaramide. Amide linkage is there. Now Kevlar is having its own defense. Means it is a long term, it is hydrolyzable because of the functional group and all those things. But this technology went on 1971, 1976 onward. Now, alpha high molecular polyethylene, it came into the picture. It is only carbon, hydrogen, carbon. So, totally chemically not material. But as I told you, they have to have a space equivalent or even more than the Kevlar. Okay. So, another way, the ethylene gas to conversion into polyethylene, that evolution took place when catalyst, even the Jagiellonian catalyst, 1950s, it was not able to produce ultra-high molecular weight polyethylene, which is being used in bulletproof jackets. Then metallocene catalyst when came into the picture, then it was possible to make a ultra-high molecular polyethylene, whose polyethylene and its fiber, whose strength is better and simultaneously it will be chemically inert than Kevlar. Then ultra-high molecular polyethylene-based technology came into the picture and tried to replace the Kevlar. So Kevlar is no longer used nowadays. So that technology sustained, Kevlar-based technology sustained. Originally it was steel-based, then Kevlar-based. Kevlar-based technology was also able to sustain 1976 to say 2005-6. Simultaneously, because of the evolution of ultra-high molecular polyethylene-based thing is used. Now, AK-47 bullet 7.62 mm into 31 mm at a meter of at the duration of 10 meters. The nowadays bulletproof jacket can ready. Okay. Now you see in our country we do not have alternative political solution. Similarly, we do not have that the state applied what is used for the canopy. So this one of this is the project what I am leading now, DFPD project. It is ongoing with the six activities. Six activities you can consider it to be six project. It's a very big project where We have targeted to develop ultra high polyethylene fiber in India indigenously. And similarly, for long term, I will be coming to the self-help polymers and composites also. We have taken targeted. We have taken the target as space equivalent for the chemology for aerospace application. Similarly, for other two. Now, another you see that inside top jacket where it will be able to resist the AK-47. Another anti advanced riot protection. In riot protection suits are commercially available. It is not like that where you can stop the lathi, danda, stone, throw and other things during riot condition. But nowadays only लाठी डंडा में नहीं चलता है वो कट्टा भी लेके चलता है. So in order to resist, we have given the name of advanced riot protection tool. We have developed significant intelligence. Bulletproof jacket is not, and it is uh, this thing we have developed and it is by CRPF in Noida. It has tested. So now we are giving the COD of this material. Whosoever will be the interested party, they will take the technology from us and they will manufacture for the Naxalite area, for the CRPF and other ones, particularly for the who will work in the riot area. Now, the another way, as I told you, as the materials demand means smart function and self-healing. Smart, these two concepts I will elaborate, and then this is Tracy. I will come in. Okay, anyway. So, define smart or intelligent. We usually call this boy is intelligent, that boy is intelligent. How could you define that the boy is intelligent or girl is intelligent? Tell me. How do you define intelligence? Anyone? Intelligence comes with sensitivity and observation. A boy or girl who is having the much sensitivity and observing ability, we can call them a intelligent boy or girl. Then what is smartness? Intelligence is not sufficient to respond simultaneously. You know many things, but she may be more smart. She can answer then and there. So that this is the concept of intelligence. And based on the intelligence, intelligent material, smart material, it is standing. So smart is a self-inspection capability and simultaneously adaptability. So these are the concepts of the self-building smart. Self-building will come into the later. So intelligent material or smart material. What we expected to the modern technological demand of cutting-edge technology today. Polymer is defined as a material or polymer which undergoes an adaptable reversibility in any of their properties as a function of technology. The property may be any of the properties, thermal property, mechanical property, optical property, electrical property, magnetic property, whatever property it may be, but its properties are such that during external stimuli, when we give it, like temperature, pressure, light, okay, it is a brain. Yeah. Suppose I go to your brain, the control room, your sensor is sensing, giving the signal to the control room. Control room is giving the signal to the actuator that you take. So this is the height part. So biomimetic provides a conceptual approach and its full exploitation lead to the generation of smart materials and structure. With this, the self-healing, now I tell you the self-healing. Then I will come, some of the example might be there. You see, anything, if it is damaged, the repairing technology is known to one. It may be welding, it may be stitching, it may be so many conventional technical things. In case of big aircraft, resin infusion, and simultaneously you could not, for curing your resin, you could not put into the oven. So the laser is being used. resin is applied in the broken zone or damaged zone, then you these are the conventional concept. People are thinking like this. The concept comes into the 2001 when a group of American scientists they have reported the self-healing in such a way they made some compound, epoxy compound, where they put some microballoons containing the liquid healing agent is a monomer to be polymerized. And they have added into the catalyst also. Now, this is the complete structure, self-healing structure you can call. When crack propagates, it will pass through the microballoon. It comes to the microballoon by the crack in the propagator, it will be broken. If it is broken, liquid will come out by surface tension and fill up the crack. In presence of the catalyst, touch in the catalyst, it will get polymerized. It will, with this concept in Nature Journal, they have published 2001. When they have published it, there is a big halla, a like human being, even if there is a cut, there is a capacity to automatically heal. So this type of material, if you can design, it will be self-healing. So there are so many BBC News, US News, so many data it has been propagated. So a material which can heal automatically. But healing efficiency, they calculated only the 70%. Okay, not 100% very difficult to achieve, whatever it may be, but it has the starting point you can say for the self-healing material. The next day, you see that scientists are also very smart, chemistry are also very smart. In that case, the chemistry, the liquid is coming out by surface tension. Very interesting. And get turned into the catalyst, it will polymerize and you are healing. The Diels Solder reaction, you know so many chemistry and chemical people, it is a reversible one. In next 2002, a material is broken, bond is broken. If you give the opportunity to reversible reaction to be come back to the original position by 2 to 10, in Science Journal 2002, it is published that based on the reversible Diels Solder reaction, we can make a material which is self-heal or self-made. Another it was there. I did a great mistake. In my laptop, it was okay. When I put in my laptop in the office, I tried to copy it by from original this one to this one. It had happened. I understand. Our concept was that ionic group. You know that if there is a ionic group, ionic group, if you make it separated, but even though if you bring into the closer to each other, they will, but electrostatically they will attract each other, they will form the bond. Now, this thing based on the Sarlene polymer, it has been proven that even if you penetrate, bullet will go and penetrate away from the flame or the material. Now, the heat will be generated. When heat will be generated, chain will be loosened. Bullet pass through, it will be loosened, they will come back to, and because of the ionic group, positive negative charge, they will again locked. So in that way, the ionic group reacts when the material could be designed in such a way that it will have the self-healing. This is some of the example what we have seen inside based on ionic group reaction, and you see that during the healing condition there is a flow by ACM. It has been shown that it passes from it by molten state, it will be coming out. That flow is shown, and the healing efficiency is greater than 92%. We have observed. Now, in recent time, based on that Sarlene and SPS study, butadiene styrene and styrene isopic study, we have developed by melt mixing and injection molding technique. We have developed some of the seeds which are self-healing, and in this case, we have achieved a 74% maximum, and in this case, 84% of different composition. So this much seed, but Sarlene and SPS blended seed, we have made it. Now we will be utilizing it along with ultra-high-temperature for the bulletproof jacket. So this stage where we have proved that we can achieve more than 80% of self-healing efficiency. In case of hydrogen material also, hydrogen is a very soft material. Some of the materials we have achieved the 69% of the self-healing efficiency. Now in this field, future of both self-healing and masking function department estimated that global market of UAV will be worth of $55 billion by 2030. So this is altogether a glimpse of the status of the self-healing polymer what is being projected. Now, in a summary of my second part, you can consider that benefits of smart and self-healing materials. So many technologies are expected as the outcome of smart and self-healing materials to fly our aeroplane like a bird of butterfly, to construct a vibration control and self-repair bridges and aerostructure, to develop our clothing like our skin, which can sense pressure, pain, temperature, to make possible that a handgun may fire only when it is held by its own owner, not in other hands. Okay, so you may not be much careful. कोई कोई छीन के लेके भी जाए कुछ नहीं कर पाएंगे आपका पिस्तौल हो तो चला नहीं पाएंगे है ना so to develop my nanorobots and molecular motors and electronic charms, and finally to develop artificial robotic arms actuated by artificial muscles to win and round arm wrestling match with a human body. So these are some of the things how I have summarized. We can predict it, and automatic things are there. And you see, in the context of sustainable material, I must say, in my content, I told you that smart and self-healing is probably a solution of sustainability. Because the features of the sustainable material is that built-in capability to automatically heal microcracks, cater the durability, cover the safety. So if it is there, you can the material will be long lasting. You need not to develop again material after 10 years or 20 years or so, since it's giving the life. So this technology is a sustainable technology. Benefits potentially to reduce resource consumption, extend the life of the products, nullify the replacement of the materials and components, reduce waste, a central component of the circular economy. So this is the benefit. So self-healing and smart is a sustainable solution in materials. The class of materials and technology would be considered as a kind of sustainable material solution. So this is my conclusion of this part. Now the second part I will take very less time. 5-10 minutes I will take. Okay. So those who are bored, they will be getting relieved. Right? You see, the crisis, all those discussions because of the two things: resource of the feedstock and clean environment. This is the global crisis. Strategic approach that you renewable resources, you have to process what you have to adapt, that is a energy efficient processes. Industrial environment should be clean, sustainable development and green chemistry. Green chemistry, I will tell you, that way some of the things. You see, the another aspect I told you, I repeatedly told the same thing, that use of plastic items, and starting from your this thing enter into the heart. So plastic is a gift of science, no doubt. Simultaneously, it may be a curse to the society. So it is inevitable in both ways how we can go into the or open your heartburn and throw it out. You have to, but simultaneously, if you see this thing, it becomes to the society. Now, the is it a gift of science regards to the society? This question, I leave it to you because our consumption is also inevitable. We cannot stop it. Plastic production 150 million tons per year globally, and about million tons plastic products are consumed every year, even in our India. So the plastic wastes are there. Now, from where it is being, you are getting two aspects. First aspect, let me first is how when it is produced by polymer synthesis of material and polymer processing is the material, raw material you take, then you process it with so many additives and other things, then you convert into the component. Now, during this process, in laboratory, some reaction you are doing into the round bottom flux or say 500 ml, whatever fume, whatever it come out, it will be meaningless. If you are able to get opportunity in big industry where chemical plants is going on. So, laboratory methods to plant method to the industrial reactor method, lab can to industrial scale when it is going, environmental concern is very important. In most of the cases, if the solvent system is used in case of polymerization or some other reaction, they are recycled also, used again also after distillation and all those things. But in all cases, there is a leakage, release of this thing, your effluent, right, your solvent in the environment. Simultaneously, is the discharge also, industrial discharge, that also again getting lot of pollution. So that's why in this we can adapt the green chemistry. I mean to say, suppose A and B, you are giving the C. C is your product, no other byproduct. Even if you are same product, if you can make it a solvent which itself will be consumed and converted into the product. So many strategies are being highlighted into the green chemistry. So I tell you, so this is also one way.